Fully factoring. When we're fully factoring a polynomial, we are just putting together some of the skills we've been working on. First, we are going to factor out the GCF. So first step, look for a GCF. If there's not a GCF, you skip that step. Next step is after you've factored out the GCF, look at the remaining polynomial. If it's quadratic, factor it into two binomials if possible. If the remaining polynomial is not quadratic or it can't be factored, skip this step. Final thing that you do is make sure to include the GCF in the final expression. This is a really common mistake. Students find the GCF but then forget to include it in their final answer. So we'll talk about that below. First example, x cubed plus 2x squared minus 8x. So does this have a GCF? Factoring out a GCF. Does it? Yes, the GCF is just x, so we're going to factor the GCF of x out of that polynomial. So x times x squared is x cubed, x times 2x is 2x squared, and then x times negative 8 is minus 8x. And you could have used the ladder to find this polynomial if you couldn't do it in your head like that. Okay, so for a little bit, we're going to ignore the GCF and just look at the remaining polynomial. Second step, if the remaining polynomial is quadratic, it is. Factor it into the product of two binomials, if possible. That means we are looking for two numbers that multiply to be negative 8 but add to be positive 2. So negative 8 and positive 1, no, does not add to 2. Positive 8, negative 1, nope. Negative 4, positive 2, nope. Negative 2, positive 4, yes. Negative 2, positive 4 multiplies to negative 8 and adds to 2. That gives me my factored form of my quadratic. So x minus 2 times x plus 4. So this is where this common mistake happens. Students stop here, circle x minus 2 and x times x minus 4. Fully factored form needs to include that GCF. So x times x minus 2 times x plus 4. That is my fully factored form of the polynomial x cubed plus 2x squared minus 8x. When we check this, there's two ways to do it. We have three factors now, and we can only multiply two factors at a time. So first option is to distribute the GCF to the first binomial. So we get x squared minus 2x. And then now you multiply x squared minus 2x times that second binomial factor. Distributive property x squared times x is x cubed. X squared times 4 is 4x squared. Negative 2x times x is negative 2x squared. And negative 2x plus 4 is minus 8x. So using this first method of first multiplying the GCF, I get x cubed plus 2x squared minus 8x. So that confirms that, yay, I factored this polynomial correctly. I just want to show you that other way that you could check. So instead of first multiplying x times x minus 2, I could first multiply those two binomials using the distributive property. So x times x, x squared, x times 4, 4x, negative 2x, negative 8. Then I have x times x squared, combine like terms, plus 2x minus 8. And now I multiply by the GCF. So x cubed plus 2x squared minus 8x. So I have again confirmed that I fully factored correctly, but I wouldn't need to do both of those to check. I just wanted you to see the two different ways to multiply. Okay, there's our first example. We had a GCF and we had a quadratic that could be factored. Let's check out this next one. So for this next one, we're looking for a GCF again. Is there a GCF? Yes, again, we have an x as a common factor, but we also have a common factor of those coefficients 2 and 4. So my GCF is 2x. When I factor out the 2x, I am left with x plus, not 4, 2. My remaining polynomial, when I ignore the GCF, is x plus 2. This is not quadratic, and so it cannot be factored into the product of two binomials, so I'm skipping this step. This is an example where fully factored form just requires me to factor out a GCF. So 2x times x plus 2. This is one where you can check it in your head, but let's just go ahead and officially check. 2x times x is 2x squared. 2x times 2 is plus 4x. And you do want to at least mentally check it because, again, a really common mistake would be to write x plus 4, and you would catch that here. Okay, fully factored form with just a GCF. Let's look at this one. All right, GCF. No variable common factor of those terms. The only common factor is 6. So my GCF is 6. I'm factoring out of 6. I have 6x squared minus 4. Let's ignore the GCF for a little bit. The remaining polynomial is x squared minus 4. It's quadratic, and so I'm going to see if I can factor it. X squared minus 4. This is the fun one, where I need to multiply to negative 4, but what do I add to? I add to that invisible x term, 0x. I need to add to 0. I need to see the same number, one positive, one negative, so that they add to 0. So negative 2 times positive 2 is negative 4. Factored form of my quadratic is x minus 2 times x plus 2. Really common to stop here, but I'm not going to stop here. I'm going to include my GCF in my answer. 6 times x minus 2 times x plus 2. Again, there's the two ways to check this. I could multiply x minus 2 times x plus 2 first. Since it's just a number, this is pretty easy. I'm going to go ahead and start by multiplying the first binomial factor by 6. So 6x minus 12. And then I need to multiply that times x plus 2 to check. So 6x squared plus 12x. Yay, minus 12x. That's what I was hoping for, to have those two terms cancel. Minus 24. So 6x squared minus 24 matches my original problem. Yay, my check shows me that I correctly factored my original polynomial. Last example. Okay, GCF. Again, these terms do not have a common variable factor since there's no variable on this constant. My GCF is just 2. So factoring out of 2, I have 2x squared plus 2x plus 1. I ignore that GCF for now. The remaining polynomial is x squared plus 2x plus 1. And now I'm going to try to factor that quadratic. By the way, if I tried to factor this quadratic and it was not factorable, my answer would not be not factorable. This would be my factored form since I was able to factor out that 2. Okay, so now I'm looking for two numbers that multiply to 1, add to 2. What two numbers multiply to 1, add to 2? That's a fun one. 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. That tells me the factored form of my quadratic is x plus 1 times x plus 1, which, since we are very sophisticated, we are going to write as x plus 1 squared. Fully factored form is not x plus 1 times x plus 1. It's not even x plus 1 squared. It is GCF of 2 times x plus 1 squared. Really great for us to practice multiplying this one to check our answer. So to multiply, I'm not going to say 2 times x squared plus 1 squared. No. X plus 1 squared is x plus 1 times x plus 1. Let's just distribute that 2 first. So I have 2x plus 2 times x plus 1, which gives me 2x squared plus 2x plus 2x plus 2. Oh my gosh. So simplifying, I have 2x squared plus 4x plus 2. Was I correct? Yes, I was correct. So 2 times x plus 1 squared is the factored form of this original polynomial. Again, to go over our steps, factor out the GCF, ignore the GCF, and if the remaining polynomial is quadratic, try to factor it. And then write your final answer as GCF times factored quadratic.